This is a problem from 4-6, and it will be one of your homework problems, or similar to your homework problems. So what I want to do is take a look at one of these problems, and I'm going to focus on number 13. So let's not worry about number 14 for now. It says sketch a graph by hand by using asymptotes and intercepts but not derivatives. So basically try to graph this thing using our knowledge of pre-calculus. Let's first examine asymptotes. So vertical asymptotes happen usually when the denominator is equal to 0, and that happens when x is equal to 0 and x is equal to 1. So it looks like we'll have some vertical asymptotes at these points. The horizontal asymptotes happen when you take the limit as x approaches infinity. And when x approaches infinity, this function, since this is a polynomial divided by a polynomial, I would just be interested in multiplying this out. Well, I won't multiply it all out. What I would do is I would be concerned about what the highest power is on the numerator and the highest power in the denominator. So it looks like the degree of the numerator is 3, the degree in the denominator is 5, and so since the degree in the denominator is larger, as x goes off to infinity, this will dominate and go to infinity faster than x cubed, and so this would just be 0. So we have a horizontal intercept at y equals 0. Now let's take a look at the intercepts. To find the y-intercept, we set x equal to 0, and when we set x equal to 0, we'll see that it's going to be a 0 in the denominator. We also note that x equals 0 is a vertical asymptote. So in this particular function, there are no y-intercepts. To find the x-intercept, we set y equal to 0, and when we set y equal to 0, we essentially just set the numerator equal to 0, and when we set the numerator equal to 0, since it's already factored, we're going to get x is equal to -4 and x is equal to +3 as our x-intercepts. So now that we have our intercepts and vertical asymptotes, we also know that we have a horizontal asymptote. But let's focus on the vertical asymptote and the x-intercept. So these are the points that are dancing around your x-axis: -4, 0, 1, and 3. And so around these things, we would be concerned about the graph, whether the graph is above the x-axis or below the x-axis. So we're going to use our original function and check points around these interesting values to see whether the function is positive or negative. So let's start by putting a value that's less than -4 into this factored form of the function. So if we put like a -100 here, this would be a negative value. This is going to be a positive value because it's going to be squared. This is also going to be a positive value taken to the 4th power. And this, when you put a negative number here, it's a negative and a negative, and so this is going to be a negative. So we got positive, negative, positive, positive, negative, so this will eventually be positive. So it looks like our graph will be above the x-axis. This is an intercept, so it'll cross at 4 or -4. Between -4 and 0, we want to know if this is going to continue down or going to bounce back up. So we put in a number between -4 and 0, like -1. If you put a -1 in here, this will end up being positive. We have a positive and a positive for these two because of the powers, and if you put a number that's a negative number here, it'll be negative. So this will be negative, which means our graph will fall below. Now 0 is a vertical asymptote, so it's probably going to continue falling below. Now we want to know what happens between 0 and 1. We put a number between 0 and 1 like a positive 1/2. This is going to generate a positive value, a positive for this factor as well, positive for this factor, and a positive 1/2 here would give a negative number. So this will be negative. So between these two vertical asymptotes we have a negative. Between 1 and 3 we have a positive, 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 and a number bigger than 1 here would give a positive. So this will be positive. And if we put a number bigger than 3, everything will be positive. So now we have a general idea of this graph. Remember that we have vertical asymptotes at 0 and at 1. We also have a horizontal asymptote at 0. We have x is equal to -4 as an intercept. We have x is equal to +3 as an intercept. Oops. Let's use a smaller. -4, +3, 0, and 1. Now based on our analysis here, we see that it's going to be positive and negative here. This is an asymptote, so let's assume that this is going to continue to go negative. Now between 0 and 1, it'll be negative, so we'll be below the x-axis. We won't cross the x-axis, so we're probably going to have this shape of the graph here. After 1, it'll be positive, and so it'll probably look something like this. It's going to hit this 3 and then bounce back up because it'll continue to be positive. Now the asymptotes say that this is going to have to come back down, and so will this come back down. So what are we looking for? This is a general idea of what the graph is, but we're going to take a closer look and try to anticipate some important points here. Since we have a piece of the graph here that goes up and comes back down, we're probably going to have a local maximum here. There may be some other critical points happening here, so we may look into that, but let's not really count on it. It's not guaranteed, but this is definitely guaranteed to be a local maximum. Another guaranteed local maximum over here. Now the graph is going to come down and bounce back up, so this is going to be a local minimum, but when it bounces back up, it has to come back down because of the asymptote. So we're guaranteed another local maximum here. The problem is not asking for inflection points, but if we were looking for inflection points, because of this asymptote, this is going to be concave up, and because of this dip for the maximum, this is going to be concave down. So it'll be probably an inflection point here. It'll continue to be concave down here, and unless something else funny happens here, we may have an inflection point, but maybe not. But in any case, it's not guaranteed. Between 0 and 1, it's always going to be concave down, so probably no inflection points there. Between 1 and 3, it's going to be decreasing, and it is going to increase, but it looks like it's going to continue to be concave up until some point before this other maximum where it's going to change concavity again because it's going to become concave down. So there's another inflection point here. Now this is going to be concave down until it starts bending towards the asymptote. So there's going to be another asymptote, another inflection point over here somewhere, past way past 3. Well, maybe not way past, but past this other maximum that we're going to look for. Okay, so that's the first part of our problem. Now let's take a look at our graph and actually take a look at a graphing calculator and see how this might look like. So here's my graphing calculator, and if I graph this using the standard window, this is all I'm seeing. That's definitely not very interesting. So nothing interesting in this picture. It looks like we're even missing some points, so this graph over here might even be way lower than what we can see. So this is a window from -10 to 10 in the x, -10 to 10 in the y. So what we want to do is we want to focus in. So let's see if we can focus in. Let's focus in to the left of -4. So I'm going to adjust my window, and we can keep our minimum x min at -10, but our x max should be, let's say -4, a little bit past -4. Let's go to -3. And if we graph this, we'll see that we're probably going to need to adjust our y min as well. So let me just graph this real quick to see that we don't get anything here. We don't see anything. We know that this graph is going to hit at 4. So if we trace it and or -4, if we trace it and put in -4, we'll see that we're at that graph. We move a little bit to the left, it looks like it's very, very close to the x-axis. If you move to the right, it looks like it's negative, still very close to the x-axis. So clearly y values from -10 to 10 isn't going to help. So I'm going to shrink this down to go from, let's go -0.1 to +0.1. Let's see how that goes. Window, -0.1 to +0.1. Let's go ahead and graph that. So if we trace this and put in the value of -4, that's our only point of reference right now. That's where it crosses the axis, and you can see by the graph that it goes up and comes back down. Let's get a trace of this. Maybe we can zoom in a little bit more even. It looks like it reaches a 0.01. So maybe if I go 0.05 to a -0.05 to +0.05, we might get a better look at this. So just the window, -0.05 to +0.05, and graph it. So here our maximum becomes clearer. Let's actually find the maximum. So let's do a second function in calc. We can find the maximum by clicking on 4. We want the left bound to be a little bit to the left of the point that we're looking at. I'm just going to scoot it over here to the left a little bit. I'll press enter. And in the right bound, I'm just going to type in 4 to get my 4 value. Whoops. Right bound, I'm sorry, it should be -4. Enter. And then a guess, you can just use this as your guess, or you can move a little bit to the left if you want. Just press enter there, and then we'll get the maximum value. So here's our first maximum value identified. So that happens up here. Now, what happens down here is probably, the graph is probably just going to go down. So let's take a look at what happens after -4. What if we graph our window from, instead of going from all the way from -10, let's start from -4 to 0, and let's go negative here. -10 to, let's just go to 1. So it looks like it's just going to dip down here. I'm not seeing any other weird effects on the graph, so I'm just going to say that this is probably going to just keep going down until you go to -infinity, so that's not a big deal. Now let's focus between 0 and 1. So, whoops, let's get our window going from 0 to 1. And let's go from -10 to 10. Well, I don't think I need to go all the way to 10. Let's graph it anyways, but I don't think I need to go all the way to 10 because I know that the graph is going to be below the x-axis. And so clearly I'm not seeing it, so this has to be lower than -10. So let's adjust the window. Let's try -50. And like I said, I don't have to go all the way up to 10. Let's just go to 1. Let's graph that and see how it looks like. Okay, we're still not seeing it, so we might need to adjust our window again. Let's go to, let's try -200. I was going to say 100, but let's just jump all the way down to -200. And let's go to 0 here. Okay, still no sign of the graph. So let's keep going further. Further negative. Let's try 1,000. And for this one, since we're going all the way up to 1,000, let's change our scale to have tick marks for every 100, so we'll get some more idea about how far down it goes, if we can even see it. Alright, there we go. We're finally seeing it. And using our tick marks, this is 100, 200, 300, 400. So probably 400, -400 would be a good minimum. So we can keep it at this, or we can change it to 400 to see it a little bit wider. Actually, this is fine. Now let's trace to find our maximum. So we'll go find our maximum. We'll use the left bound to be 0.5. That looks like a good left bound. Right bound. Let's just go a little bit past our maximum value just by hitting the right arrow a few times. And so at some point over here at 0.89, it looks like we have our we are on the other side of our maximum. So let's enter that, and let's use the same thing for our guess. And here's our local maximum at about 0.82 with a maximum of -281. So here's our maximum. Now over here we're going to see another maximum, a minimum at 3 and a maximum at some point past 3. So let's see if we can find that in our calculator. Let's adjust our window to include, let's put 1, and let's go to 5 for now. This is going to be above the x-axis, so we can start with 0. I'm going to put -1 for starters. And let's go have our y max jump to, let's try 10. Let's see if this is gonna catch anything. And the scale, let's put our scale back to 1. So enter, graph. Okay, so again, it's hard to see. It looks like it just drops down, and I don't even know if that's 3. I think we started with 1, 2, 3. So 3 is probably somewhere over here. Let's check by tracing. So let's trace. X equals 3 is right here. So if we move a little bit to the right, this is even smaller than what we have here. So it looks like we have to shrink our y values down kind of low. And if we keep going further, this looks like it's still getting higher and higher. I'm looking at 0.009 and now it's 0.01. It looks like it's going to continue to get higher, so I'm probably not going to be, well, I might not even be able to catch my maximum with x is equal to 5. So let's change the window again. I'm going to change my x max to be 10. And we saw that we're getting really small values for for the the y values. So I'm going to change my y min to go 0.01, and then my y max to go to positive point. Let's try 0.1 for now, and let's graph that. So here's a bounce to trace it, and type 3. Here's our minimum at 3, which was expected, and then it looks like we have a maximum of happening over here. It's if we go to 5, we're still not quite at that maximum, so if we go all the way to 8, maybe we'll see we get beyond that maximum. Alright, let's actually find the maximum. Go to calculate. We're finding the maximum. The left bound, I'm going to type 3 in for the left bound because I know that that minimum is happening over there. Now the maximum, I'm going to go past 5. I think we had 8 last time for the right bound. And then I'm going to use the same value for my guess. So here's our maximum value. I'm not getting a good picture here, so I'm just going to adjust the window one more time. To go negative 0.05 to positive 0.05. That'll just give me a little bit more room to view my values down below. Alright, let's do that trace again. And we're going to find the maximum value. We'll use 3 for the left bound, 8 for the right bound, and the same number for your guess. So here we find both our minimum value, which we don't have to identify because it's already there, but our maximum value that's given over here. So we have 3 maximum values that we found that we wouldn't have been able to find just by doing a standard graph using any graphing calculator. We found one minimum value at 3. This maximum value is an interesting maximum value because it's a very negative number, negative 281. And so we wouldn't have been able to see these nuances of the graph with just one picture. We needed to do some serious zooming in to pieces of the graph to find these things. All right, so hope that'll help you work on your homework.